Imagine a world where every user, device, and request is verified constantly. That's zero trust architecture in a nutshell, and it's quickly becoming the standard for securing modern systems. In this video, we'll explore why perimeter security alone isn't enough, how zero trust changes the game, and what steps you can take to implement it. Let's get started. Traditional firewalls assume that if you're behind the perimeter, you're safe. But in a cloud-first world, employees and workloads can exist anywhere, and attackers often move laterally once they breach that perimeter. Zero Trust says, never trust by default, always verify each request. First, you confirm every request's identity, user, device, location, and even behavior. Second, you grant the smallest set of permissions possible. And third, you behave as though an attacker might already be inside your network, limiting lateral movement. Next, let's visualize how a zero-trust environment might look. Here's a simplified diagram. 1. A user and device send a request through a policy enforcement point or gateway. 2. That gateway consults an identity service to authenticate and authorize, maybe via a token or certificate. 3. If valid, the user can access the microservices or apps. 4. All actions are logged for real-time monitoring. This ensures every request is explicitly verified, not just once at login. Next, let's see a real-world example to tie it all together. For instance, a user connecting from home triggers the policy gateway. The system checks their device posture, is it patched and secure, their identity, and the requested resource. If it all checks out, they get a temporary token for that microservice. If they try to access a different service, the gateway reevaluates them. This drastically reduces lateral movement if an attacker compromises an endpoint. Whether you're using Azure AD, Okta, or an internal identity provider, you want each service to trust the token from your policy gateway. That means strong IAM with multi-factor, device checks, and continuous monitoring. Next, let's briefly see a code snippet that demonstrates a gateway approach in Node.js. Here, each request hits a Node.js middleware that checks for a token, verifies identity with an external service, applies a policy check, and logs the access. This approach ensures verify explicitly and least privilege core zero trust principles. Let's move on and wrap up with a final conclusion. That's the essence of zero trust. Never assume a request is safe just because it's inside the network. Instead, verify every user, device, and action. Use strong identity, policy enforcement, and monitoring to shrink the blast radius if a breach occurs. Thanks for joining me, and let me know in the comments if you're adopting zero trust. Don't forget to subscribe for more security and architecture insights. See you next time!